Hi guys, welcome back to Symbolic Logic Part 22. In the previous session, we have studied about rules of inference and we have also used those rules to solve complex problems. So, let's recap what we have studied previous. So, in the toolbox, we have 9 rules of inference. One is modus ponens, modus tollens, hypothetical syllogism, distinctive syllogism, conjunction, constructive dilemma, simplification, absorption, and addition. We have used all the formulas in this toolbox and we have applied those in the problems to solve without the help of truth table. So, in addition to these rules of inference, we are gonna add few more rules to make the problem solving pretty much easier. So let's see what's the second thing which we're gonna today is rules of replacement. So first we have studied about truth table and solve the problems. When I say about problems, I mean the finding the validity or invalidity of an argument. So using the rules of inference and before using rules of inference, we use truth table to find the validity. And when it comes to rules of inference, we have also studied how to do with the help of these rules without truth table because truth table is troublesome and complex. So, these 9 rules will not be enough for every type of given argument. So, they are introducing replacement rules. So, testimonial. So, what's the difference between rules of inference and rules of replacement? Why they didn't added the extra rules to the inference, but why they gave a new name called rules of replacement? So let's see. So in rules of inference, given the premises, getting the conclusion as a tautology. And rules of replacement, one form can be tautologically equal into another form. In other words, one form can be replaced by another equivalent form without modifying the truthiness of the statement. This is called rules of replacement. So, in rules of inference, we will have the premises and we will have a conclusion, and we will be like tautology means LHS is equal to RHS. We will be proving that both the sides are true. But when it comes to replacement, what we are gonna do is we will be replacing the premise or one form to the another form without modifying the statement. So we are replacing the form itself. So that's why we call it as rules of replacement and cannot be added in rules of inference. So let's see each of the rules with an proof. The first rule which we have is De Morgan's law. Shortly we will call it as or write it as DMM. So we have negation P conjunction Q by conditional negation disjunction negation Q. So if you have negation P conjunction Q in a question, you can replace it with negation P disjunction negation Q. The same goes for the second law of De Morgan's. That is negation P disjunction Q by conditional negation P conjunction negation Q. So let's see how to prove with the help of truth table. So how we gonna prove is we have PQ as standard values, and then let's take the left hand side and right hand side. And what we gonna prove? Left hand side is equal to right hand side as usual, which we have applied to the previous problems. So we are solving LHS, which is negation P conjunction Q, and the RHS, which is negation P distinction negation Q. By solving, we get the values of like F, T, T, T. So the LHS is equal to RHS. That's why the first rule is valid. Valid. So let's go to the second one. So the second rule of replacement is commutation law. What the commutation law states is P distinction Q is equal to Q distinction P. And the second law of commutation is P conjunction Q is equal to Q conjunction P. I hope this is pretty easy to understand and apply in problems. So let's see the third one. Association law. What the association law tells is we can replace P distinction Q whole distinction R by P distinction whole Q distinction R. And the second law states that P conjunction Q whole conjunction R, we can replace it by P conjunction whole Q conjunction R. Even for this law too, we can apply truth table and prove with this LHS is equal to RHS, then prove. So for every law in rules of replacement, we will be using truth table to prove LHS is equal to RHS. That's why it is a valid argument. This is for proof of theorem. For proof only, we will be using truth table to prove that the theorem is correct. So the fourth rule of replacement, what we have is distribution law. Same as P conjunction Q distinction R is equal to P conjunction Q distinction P conjunction R. The second what we have is P distinction whole Q conjunction R is equal to P distinction Q conjunction P distinction R. So the fifth law which we have is double negation law. Negation P is equal to P. So the sixth one we have is transposition law. P implication is equal to negation Q implication negation P. The seventh we have as material implication law. P implication Q is equal to in negation P distinction Q. So the eighth we have is material equivalence laws. That is biconditional Q biconditional P implication Q conjunction Q implication P. So the second one is we can also replace it by P conjunction Q distinction negation P conjunction negation Q. So the next law which we have is ninth law is exportation laws. That is P implication Q implication R is equal to a biconditional P conjunction Q implication R. Next the last formula. So we have tautology laws, which is P distinction P is equal to P. P conjunction P is equal to P. So we have 10 laws in this replacement rules, which we will be using in the upcoming sessions to solve more problems. So we will be combining all the rules which we have studied so far, that is rules of inference, and we will be also using the replacement rules to solve the problems without the use of truth table to prove whether the given argument is valid or invalid. So in the next session, let's see how to solve the problems using the rules of replacement.